Hi, good afternoon. These will be my presentations about Pokayoke templates. Um, this will be an exposition for my class of Stay 1. I think that's how you call it, Stay or internship, but I will call it Stay 1. My name is Andrés Alejandro Rangel Esparza, and I'm studying in the electronics major, not minor, in the group 04A. So we're going to start. First of all, I'm gonna give a little description about what's a Pokayoke and what's a template. If you ask why I'm doing this presentation in English, is because the company that I work for asked me to do this in English so they can show this presentation to other employees. So this will be yes, in English. I hope you like it. First of all, what's a Pokayoke? A Pokayoke, it's a mechanism. Well, the word or the term was invented in Japan. It's a mechanism that is put in a place to prevent human error. That's a short description about a Pokayoke. And in my words, a Pokayoke it's any machine, any process, any technique, anything that will reduce human error or that will reduce errors or accidents. We we can see here a Pokayoke diagram right here. Um, this one is very useful because you can locate your like in your situation in each one of the points, and you can go from there. So, but I usually first I visualize the problem and I start from there, but you can do it however you want. And essentially, a Pokayoke is a safeguard that prevents a process from proceeding to the next step until the proper conditions have been met. So, a Pokayoke template would be a template that helps to reduce human error and helps like strictly mark the steps that you have to take to complete that process. And what's a template, you may ask? A template will be any kind of machine, any kind of base, any kind of mechanism that helps you make a process or pattern many times in a row without changing the outcome, for example. Here in the description we have the same description or the description that says a shaped piece of metal, wood, card, plastic, or other material used as a pattern or process such as painting, cutting out, shaping, or drilling. But the real description for a template is that something that helps you make the process the same each time you do it. And that's how they work it here in the company that I work for. So the problematic of these Pokayoke templates. First of all, a little bit about the company I work for, the DMU Industries, or DMU in español, specializes on plastic injection and parts and manufacturing processes. With the plastic parts that they produce, my job was to design and program two Pokayoke templates because the enterprise that we were selling the parts to needs to assure that these parts are going to have the best quality and made or manufactured with the best process possible. So, in the case of the first template, this was a header template. You can see it right here. A header is the part of the car that you rest your head on. This is going to be for a Nissan Versa, I think. I'm not really sure. I don't sell them. I just make the template. So this goes in a Nissan Versa, and in the back, you know, in the where you rest your head. What was happening here? So first of all, here we can see how the piece comes out of the machine, the injected machine. It comes without the plastic, you know. And and the process is to paste this plastic or this foam on top of the plastic part. So what they were doing was doing it with brush, but the brush didn't work because it was very uneven, and you didn't, and it wasn't always the same quantity of glue, and and the foam was moved a little bit, and because they were doing it, like, if you can see my hand, they were grabbing it by the hand and gluing it with a brush. So what's the process of thinking of the problem? So we have to build a template from zero, from scratch, a base, so we can put the piece, so we can put the part and it doesn't move. I'm going to show that later in the presentation. And sorry, and what I imagined was applying the glue with a glue gun, a modified glue gun, so that if we have a timer and we put that timer in the glue gun, it will always be the same quantity of glue for each piece, you know. So moving on. Oh, sorry. And the other template was a clip template. You know, you can see here this piece. I don't know where this piece is going to. It's for a car. I don't know where or what is it. But what I know is that, like, 100% of the time it needs these two clips. Like if this piece goes to Nissan or to Honda without these two clips, it doesn't work. They return it and they fine you because they are paying for them to receive the piece with these two clips. So here the company had problems because they sent it some parts that they didn't have the clip. So this was really a bad problem. So a buyer from that company, I don't know what company this is from, I think it's Nissan, came and said what we're going to do. So we occurred, like, I helped a little bit with the idea to make a template that forcibly you have to put the part on, and with some pistons force the clips in the piece and give the piece a check mark, you can say it, so that you know that if it has that check mark, the two clips are there, and it will only put that check mark if the two clips are in there. We did this with also a PLC and a camera that compares a lot of images. So it compared an image of the part with the no clips on and the clips on, and it will compare these images so that when the part had these clips on, like, it will compare them and say, oh, it has the clips, so I'm going to press them, and then I'm going to give the check mark, the quality mark, you can say it. It's only like a little dot that is, I will explain, like, more technicalities later, but this was only the problems that we have. Objectives. The main objective of automatization is to develop and implement two templates that will give and enable the semi-automatization of two distinct processes involved in the manufacturing of products sold by DMU. The objective of this, I was also very curious, and I asked the leader of this company that why are we doing this, because, like, it costs a lot of money, the PLCs cost a lot of money, the templates cost a lot of money. Is it worth it? But he told me that yes, it is worth it, because when your customer comes and sees this template that is automatized and there's like 100% sure that the piece will come out right, they pay whatever thing you like, or whatever you ask them for, so that their process could be 100% perfect. So that's the objective. Make the process perfect. It's not always going to be perfect, but you know that's how they explain it to me. And overall, this project is an essential step towards improving DMU's production processes, reducing costs, and increasing efficiency, all while maintaining the highest standards of quality. Also, the templates work as a charm to reduce costs because you are not wasting glue or you're not wasting plastic parts, you're not wasting time. And in a company like this, time is money. Next, this is the objective of each of the templates. We can see here a little bit of the pictures of the templates, but the objective of every template is here in the presentation. So we're moving on. First, for the process, I separated the process in three parts of designing, building, and programming. That's all I had to do because I was only they only gave me this project to do that: design the templates, build the templates, and program the templates. So first, I designed this list of materials. I designed it myself because when you work in a company, you have to register everything you buy or everything you ask the company to buy for you, so you can make the project. So here is a little example of the list of materials I made. It all have the UPA logos and the company logos. Also, you have to design an activity plan so that your boss can see what are you doing each day and where are you in this process, for example. This activity plan I also designed it myself. Uh, And as we can see here, that's an example of all the activities that are you are going to make for the template, and all the weeks that is going to be this project, and the ideal time you are going to wait. Let me put that. The ideal time you're going to take doing the project, and the real time you you took doing that step. For example here, if the fabrication of the base, the ideal time I calculated was 2 weeks. I did it in a week and a half, so that's great. But in other cases, sorry. Oh, wait.